Hello. Please hit like button and subscribe my channel. Also press bell icon for future video notifications. Thanks.
Using a combination of telescopes, including the Very Large Telescope of the European Southern Observatory, ESOS-VLT, astronomers have revealed a system consisting of 6 exoplanets, 5 of which are locked in a rare rhythm around their central star. The researchers believe the system could provide important clues about how planets, including those in the Solar System, form and evolve. The first time the team observed TOI 178, a star some 200 light-years away in the constellation of Sculptor, they thought they had spotted 2 planets going around it in the same orbit. However, a closer look revealed something entirely different. Through further observations we realized that there were not 2 planets orbiting the star at roughly the same distance from it, but rather multiple planets in a very special configuration, says Adrien Leleu from the Université de Genève and the University of Bern, Switzerland, who led a new STU. The new research has revealed that the system boasts 6 exoplanets and that all but the one closest to the star are locked in a rhythmic dance as they move in their orbits. In other words, they are in resonance. This means that there are patterns that repeat themselves as the planets go around the star, with some planets aligning every few orbits. A similar resonance is observed in the orbits of 3 of Jupiter's moons, Io, Europa and Ganymede. Io, the closest of the 3 to Jupiter, completes 4 full orbits around Jupiter for every orbit that Ganymede, the furthest away, makes, and 2 full orbits for every orbit Europa makes. The 5 outer exoplanets of the TOI 178 system follow a much more complex chain of resonance, one of the longest yet discovered in a system of planets. While the 3 Jupiter moons are in a 4:2:1 resonance, the 5 outer planets in the TOI 178 system follow a 18:9:6, 4:3 chain, while the second planet from the star, the first in the resonance chain, completes 18 orbits, the third planet from the star, second in the chain, completes 9 orbits, and in fact, the scientists initially only found 5 planets in the system. But by following this resonant rhythm they calculated where in its orbit an additional planet would be when they next had a window to observe the system. More than just an orbital curiosity, this dance of resonant planets provides clues about the system's past. The orbits in this system are very well ordered, which tells us that this system has evolved quite gently since its birth, explains co-author Jan Alibert from the University of Bern. If the system had been significantly disturbed earlier in its life, for example by a giant impact, this fragile configuration of orbits would not have survived. Disorder in the rhythmic system. But even if the arrangement of the orbits is neat and well ordered, the densities of the planets are much more disorderly, says Nathan Hara from the Université de Genève, Switzerland, who was also involved in the study. It appears there is a planet as dense as the Earth right next to a very fluffy planet with half the density of Neptune, followed by a planet with the density of Neptune. It is not what we are used to. In our solar system, for example, the planets are neatly arranged, with the rocky, denser planets closer to the central star and the fluffy, low-density gas planets farther out. This contrast between the rhythmic harmony of the orbital motion and the disorderly densities certainly challenges our understanding of the formation and evolution of planetary systems, says Leleu. Combining techniques to investigate the system's unusual architecture, the team used data from the European Space Agency's CHEOPS satellite, alongside the ground-based ESPRESSO instrument on ESOS VLT and the NGTS and Speculos, both sited at ESOS Paranal Observatory in Chile. Since exoplanets are extremely tricky to spot directly with telescopes, astronomers must instead rely on other techniques to detect them. The main methods used are imaging transits, observing the light emitted by the central star, which dims as an exoplanet passes in front of it when observed from the Earth, and radial velocities, observing the star's light spectrum for small signs of wobbles which happen as the exoplanets move. The team used both methods to observe the system, CHEOPS, NGTS and Speculos for transits and ESPRESSO for radial velocities. By combining the two techniques, astronomers were able to gather key information about the system and its planets, which orbit their central star much closer and much faster than the Earth orbits the Sun. The fastest, the innermost planet, completes an orbit in just a couple of days, while the slowest takes about 10 times longer. The 6 planets have sizes ranging from about 1 to about 3 times the size of Earth, while their masses are 1.5 to 30 times the mass of Earth. Some of the planets are rocky, but larger than Earth. These planets are known as super-Earths. Others are gas planets, like the outer planets in our solar system, but they are much smaller. These are nicknamed mini-Neptunes. Although none of the 6 exoplanets found lies in the star's habitable zone, the researchers suggest that, by continuing the resonance chain, they might find additional planets that could exist in or very close to this zone. ESO's Extremely Large Telescope, ELT, which is set to begin operating this decade, will be able to directly image rocky exoplanets in a star's habitable zone and even characterize their atmospheres, presenting an opportunity to get to know systems like TOI 178 in even greater detail. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.